And today I would like to introduce you to Nexus, which is a new project that is going to, we hope, really make a big difference in developers' world in terms of empowering them to debug and profile the GPU in a much revolutionized manner. So a few words about kind of the current state of the art in terms of programming landscape today. Typically, a developer developing a game has to code his application within Visual Studio, which is kind of the golden standard for application development for CPU code, multi-core code and whatnot. So you can create, edit your code, you can build it, you can debug it, and pretty much profile it. So the bulk of the action happens within Visual Studio. And then on a totally separate tool set, you can do some GPU work. You can potentially create shaders and some kind of standalone creation tools like FX Composer or Mental Mill. You can debug your graphics application using PerfHUD or Pix, Microsoft Pix, for example. You can also profile your application using Pix and PerfHUD. So you have a variety of totally disjointed tools that the programmer has to jump through to go back and forth between his CPU workloads and his GPU workloads. So it's kind of a patchwork of a tool set that one needs to juggle. So what Nexus tries to do, next slide please, is actually to bring GPU and CPU computing together, developing the code for these processors into one place, which is Visual Studio, which is really the place where developers want to be. So with Nexus, we're trying to make it very much seamless to develop GPU code and CPU code, but also to allow you to compile, to fix your compilation errors within Visual Studio, to also debug your shader code. And I will give you a demo of that as to how integrated the debugger and the profilers actually are now within Visual Studio because of Nexus. Next slide, please. So really, Nexus, GoDaddy Nexus is trying to revolutionize the application development for what we call heterogeneous platforms, which are essentially platforms made out of multi-core CPUs and multi-GPUs. And we want to make this environment as homogeneous as possible, such that it feels like there's only one problem that the developers are programming for, and it doesn't have to go through groups to assemble everything together. The point we're looking to make today is really Nexus combined with GF100 allows us to really build a revolutionized development environment for DirectX 11. Without Fermi, GF100, it's impossible for us to actually build Nexus or to bring Nexus to a level of sophistication, of power that you're going to be able to see. There are specific features within the GF100 architecture that makes Nexus possible. Without it, the feature set would be much more reduced. Again, it is fully integrated into Visual Studio. How many of you are familiar with Visual Studio? Yes? Yes? Okay, so this is really, this is like the Microsoft Office of development. Really, there's no way to get around it. Nexus enables essentially what and it is the world's first hardware-based shader debugger ever built. And you will see that when you debug a shader, it's not an emulation, it's not a trick, it is actually stopping the GPU, and Nexus allows you to step the code on the GPU for given pixels, for given vertices, for geometry shaders, for tessellation shaders, for DirectX 11. The GPU becomes basically a processor that is fully debuggable, that the developer through Nexus can actually fully understand. Also, it is very important within the heterogeneous computing paradigm is the ability to trace CPU and GPU workloads on the same timeline. When you program a PC today, again, you have multi-core CPUs, you have multi-GPUs. It is extremely difficult to understand who's doing what and who's potentially causing stalls onto another processor. You know, you may be doing something complicated on the CPU, and then the GPU is waiting for the result of that computation. It's true within the various cores of the CPU or the GPUs. It is also true between the CPU and the GPU. And Nexus, for the first time, actually brings to the PC the ability to trace all those workloads and potentially also those dependencies. Also, in addition to memory transfers. So at last, really, for DirectX 11, we believe that Nexus combined with GF100 is really going to make it very, very easy for developers to embrace the cool new features that DirectX 11 has to offer. So to give you also an idea of the complexity of Nexus, because it is actually it's a big investment from NVIDIA. It was we started quite a few years ago, and there's a sizable actually development team working on it because this is a very complex problem. We had to really design an architecture, a software architecture that enables really those goals, and it's a big challenge. So first and foremost, Nexus is actually a client-server architecture. There are two big components to Nexus. There's a host that is essentially visible from within Visual Studio, where we can actually edit the code, debug it, look at basically the values while we are debugging the variables, or launch basically sessions for profiling and navigating through the results of the profiler. And then this host has to talk to the application that can be local to the system or remote. So we can actually enable remote debugging and remote profiling in a similar way that game console developers are used to do for PlayStation 3 development or Xbox. The advantage of having a client-server architecture is that when you want to do debugging and you want to set a breakpoint on the GPU, and you hit a breakpoint on the GPU, well, the GPU has to stop, which means that your desktop freezes, right? Because the GPU is actually stopped at a given location because you want to debug it. And therefore, if you have Visual Studio running on the same system that you want to debug your game, well, it's not going to work because you're in a frozen state. So for this to kind of work around this problem, which is actually an advantage, we had to build this client-server architecture so that we can actually enable a remote debugging session on a client on a remote system, so that we can actually step through that impacting the whole system. I will show you also during my demo that we have also local debugging solution that developers can take advantage of, and we'll go over that. The other advantage of having a client-server architecture is the ability to actually bias as minimally as possible a performance session. When you profile an application, you want to have the minimal amount of disruption while you're actually analyzing the system in responding to the execution of the application. So being able to actually upload a build onto a variety of different systems that can be low-end and high-end, doing some profiling very quickly and mining the results of those optimization sessions is actually a desirable feature as well. So without further ado, I would like to the next item, and actually, if you want to move over again and bring your chairs, if you want to, I'll give you a quick demo of Nexus in action.
Nexus in action?
This is Nexus.